Hello, this is Dead Hamster, and today we're going to be recording a new tutorial on how to make custom levels for Mario Kart 64 using the Tarmac 64 toolkit, which will be a link included in the description below for download. Also included in the description will be links to the Overkart 64 Discord, which I recommend you to join if you're looking to be making or distributing your custom levels to others in the community. Plenty of us there to play test and give critique and things of that nature. So we're going to be looking not at actually any 3D modeling. I expect you to have a pretty decent amount of 3D modeling experience before coming into this. If this is your first video game that you're trying to make custom content for, you should find something else. You will not be having a good time. You want to have a little bit of experience elsewhere and then bring that into here. So on that note, we're going to switch over. I'll be working today in 3ds Max. We use FBX files for all of our model exports, so Blender is supported, as well as any other software that can export to a proper FBX format. We're going to begin by making a full level here. As I do, I'll quickly describe some of the restrictions and things of that nature. When I start facing north and create a box usually about 175 units wide. So the width here, 175, say about 500 units. Height doesn't matter. Really, I should have created a plane and not a box, but this is fine as well. All objects have to be centered at 0 for their positions, and their rotation must also be 0. The scale must be 100. When Tarmac reads model data, it does not read the translation or rotation of object data. So if you do have any type of scale or rotation or movement on the object itself, this will not be read and it will be misaligned when you go to put it in game. If you need to move an object, it should be a mesh, and you should move the actual model geometry, the vertices, the faces, not the object. You can see here that this is still at 0, even though I've moved the geometry. It's okay to move the geometry. The objects themselves all have to be at 0. That's very important to maintain that. So moving this back to where it was, we're going to start off just with a plane. Now this gives me a good opportunity. You can see I have back facing enabled. Faces are only drawn in one direction, so you should be sure that you have your normals flipped to face the proper direction. I'm going to put the start of my road right here, and I'm now going to quickly model the rest of it just by doing something simple like this. So I'm welding these verts together as I drag these faces out. Got to make a little turn here. Do it this way. So I'm just making clones of the geometry and attaching it to the existing. Lots of different ways to model, as long as you end up with a mesh of geometry at the end, all triangulated preferably. Everything is fine. There's no specific way that you have to do anything. You do have to have, real geometry at the end. You can't be using splines or any type of weird primitives or anything like that, but otherwise you're free to use any type of modeling technique that you've picked up over the years. So we want to try to straighten this last bit out. I didn't do a very good job attaching everything. That's fine. You can see here the turn is not very even because I didn't properly space it. I'm just going for speed at this moment. We're going to take this. I'm going to use a mirror modifier. Drop this here and do the same thing on the Y. Mirror modifier, this time on the Y-axis. Okay, so we have our road. Now I need some grass along the outside. I'm going to take my edges all my edges on the outside. Again, we're just going for something real simple here. Okay, I'm going to take these, I'm going to do an extrude scale on the edges, which will give me some nice exterior areas. And then I'm going to extrude the edges upwards to get the walls. This looks kind of funny and it looks kind of smoothed out. We're going to get rid of all the smoothing groups. There are no smoothing groups in the actual game, so it's not something we have to worry about. Last step, select these inside edges. And we're going to basically do the exact opposite. Pull it inwards instead. And same thing, drag it up. So this is our level for today. It's going to be very simple, very basic. We have to apply materials. Now, materials only use one thing, a diffuse texture. I like to use multi-sub-object materials. But again, as long as it is a material with a diffuse map that the FBX file is able to read, you can use materials however you are familiar in your 3D editor. So I'm going to have 3 sub-materials. The first one, a standard material, my diffuse bitmap. I'm going to find a road texture. Next material, again, standard. I'm going to use standard for all my materials. A bitmap in the diffuse, I'm going to use grass. And then one more, again, a standard material. Bitmap, in this case, a brick wall. Those will be our 3 materials we use for this. I'm going to assign those now. Assign the entire submaterial to the object. And then go through and assign the individual IDs. So when using a multi-sub-object, you're going to set the ID to match the one of the texture that you want to use. I'm going to flatten out these walls so that they're the same height. Okay, so now next thing, UV maps. All faces have to have a UV map. There is a limit to the number of tiles that a single triangle can have for a UV map. This is very important. You can only have up to 16 repeats, I believe it is. It may be 32, but I'm pretty positive it's 16. 16 repeats across a face. After that, the engine can't hold any more data. It uses a 16-bit integer, and based on the way that the value is stored, again, 16 tiles is the max number of times that a texture can repeat. And so what I mean by that, for example, in this case, the texture repeats 16 times across the whole stretch, or here you can see it repeating 16 times from top to bottom. Obviously, this is a bit overkill, but if these triangles were excessively large and I was trying to use a small texture tiled across them, I may have to subdivide the triangle into smaller pieces in order to make sure that I don't overgo this limit. I'm going to do a very simple box map for the UVs in this case. I'm not going to do an unwrap. I'm not going to take time with individual elements. There is a UV normalizing function which will take extremely far triangles and center them. So as long as you don't over tile a triangle, you can do a large UV map like this. So something like that. And now you can see that the textures are properly applied to the surfaces and the geometry underneath. Now that we have our 3D model that we're going to use for the race, we need to actually set it up for the game itself. So in order to do that, I have a tool set I use. There's another tool set as well for the Blender version. However, to make this a little bit more comprehensive so you understand what's going on, I'm going to do some of these parts by hand. Normally, I would type in the number of sections that I'm going to have into this box, and it would create a bunch of objects. Instead, I'm going to create those myself to give an example of what we're doing here. We're going to create a couple boxes and name them after the sections. And what a section is, you're going to be taking your level, which usually will be a bit larger than this, and breaking it up into smaller pieces to make it easier for the game to render so that it doesn't have to draw everything at once. You should try to subdivide the level to break it up and make it easier to render and select what will be drawn. On extremely advanced courses, you'll actually be selecting and manually adjusting those lists to optimize the game. For less advanced courses, not so necessary. You do want to subdivide the level though. In this case, I'm going to make 2 sections. Because this is so basic, I don't really need to subdivide it at all. But just for the experience, I am going to. So again, first there is section 1, and then we're going to make another cube called section 2. Now there also needs to be a cube called course master objects. This is for rendering. So there will be collision, which is where you're actually going to be colliding with the geometry of the level, and there will be what's shown and displayed to the player, and those can be 2 separate models. The reason you would do something like this is for things like water or for details up above the level. You don't want to necessarily render collision checks on those, which is extra processing time, so you remove those from the collision model. We won't have that in this case because it's simple, but we will still go through those steps. So we're going to take our model here. We have to separate it by material. So I want to first make a clone. We're going to call this course backup, and we want it to be a copy. Okay, so I have my course. I need to divide it by material. I'm going to take all of the road, and I'm going to detach it into its own object. We'll call it road object. And we'll take all the grass, attach it to grass object, and then all the brick will go into brick object. Now you can subdivide these smaller so that it's easier to select and cull individual parts of the level. Again, with this being so simple, it's not something we'll cover today. There's now nothing left, so we can delete this object. We have our 3 pieces, the road, the grass, and the brick. We're going to, again, break these into 2 sections. So taking my road object, I'll have section 1. I'm going to call that road 1. And then this will be road 2. Same thing for the grass. Grass 1, grass 2, and last the brick. Brick 1, brick 2. Now I want to take these objects and put them into the section that they belong in. So all 3 of these belong in section 1. So now I can see that part of the level. And all 3 of these belong in section 2. I can see these in this part of the level. Okay, I had to pause for a second there. So now we're going to actually name them after their surface type. So there's a list which will be available throughout the Discord and also on Micro 500 Wiki. It also is able to be set in the program itself later on, but we want to set them ahead of time. The road is going to use material 1. The grass is going to use material 8. And the walls will use FF. Now that's hex, In decimal, this is 255. So going back here, the road, we're going to name 1 underscore and then some unique name. I'm going to use part 1. That's 1 underscore part 2. Just to show what it is that we're typing in here. So again, that was 1 part 1, 1 part 2. This can be anything as long as it begins with the surface ID and an underscore. For example, 1 bologna sandwich is perfectly fine. 1 grass area is fine. 1 Frankenstein, whatever. It literally can be anything that you want to type as long as it is unique. You cannot have 2 1 Frankensteins. You would have to have something like Frankenstein 2 or whatever the case would be. So we're going to use part 1 in part 2. For the brick, this was 255. So we're going to use 255 underscore part 1. And 255 underscore part 2. And then for the grass, it was 8. We have 8 part 1, and we have 8 part 2. Now the next part would be for creating the items and the spawn points and everything else. For that, I am going to use the script just because it's a little bit quicker to set up. But again, it is the same thing where you just have to make sure that there are boxes with specific names. And I'll go over the details right now as this creates everything. So we have a box called objects dash item blocks. Then we have objects dash piranha plants, objects dash red coins, and objects dash trees. A cube with each of any object with named each of those. The children, wherever they are positioned, will be the location of those items. The Blender script is a little bit different than the 3ds Max script. Again, I recommend joining the Discord server. We'll be able to go over that in detail. For now, I'm just going to place a few items. I'll duplicate it so that I have multiple items listed as children under the parent objects item blocks. Again, cloning so that they're children. And we'll do 6 item boxes on the top here. I don't want any piranha plants. I'm going to put a couple trees randomly throughout the level. Oops, wrong thing. Undo. A couple trees randomly throughout the level. And we should have 8 red coins altogether. If there is not 8 red coins, it won't spawn any. So if you don't want to put any in your map, you don't have to. But if you do have to add all 8. Nope, I did. That is exactly 8. Perfect. Okay, so that's the coins, the path or the coins, the trees, the piranha plants. The path markers use a spline. In Blender, it uses a Bezier curve. So you'll have to create a curve with points that the AI will follow, and then map those to the geometry. I'm going to be a little lazy here and just kind of do that. Now, 3ds Max has this wonderful tool called Normalize Spline. Ideally, when you're making your path markers, you want each marker to be exactly 20 units apart. This is sometimes a little bit more difficult than it might need to be, but this modifier right here lets me do that. So I end up with 311 points. The maximum number of points is 800. If you go over 800, you will need to simplify the spline so that you have less than 800 points. If you cannot do 20 units apart without going over 800, you have to extend it to 25, 30, however many units you may need. So we have our path markers now, our item boxes, the coins, the trees. To export the path markers, the Blender script again has a different function. For us, I'm going to hit the export button. I'm going to save it as demo in this case. We're also now going to export the actual model. So we're going to go to File, Export. Going to go to that same folder, and I'm going to save it as an FBX file. We should deselect pretty much all the settings. We don't want smoothing groups or instances or animations or cameras or lights. I don't think it'll cause any issues, but I disable these just so that I don't have to worry about it. We're going to export that, and we're now ready to try using the actual program here. So we'll open in Tarmac 64 the course compiler. When this loads up, we'll hit the load button, and hopefully this works the first time. Let's see. This message may appear. If it does, it means that one of your materials did not have a diffuse texture. This is normal because there's always at least one material in the scene without a diffuse texture. If you have this error for one of your actual materials, though, that you're trying to use, this is a problem. You'll have to look into that and fix it. In this case, this is okay. We only had the one error. We now have to load the other file, the pop file. This is the path markers and the object positions. So once both of those have been loaded, we can use WSAD, and something doesn't look right. Yeah, we don't have... Oh, I know why. We created our surface geometry. Here's the surface geometry, but we forgot to do the rendering geometry. We're just going to take a copy of the parts we already have. We're going to clone these. I actually have a tool that will let me clone them all at once. You may have to clone them each individually. That's fine. And then we're going to put the clones into the Course Master Objects box. So that's all better now. We're going to re-export this. So to clarify again, there's two sets of objects. There's a set used for collision that goes in the section box that's subdivided by section. And there's a second set of objects that goes under Course Master Objects, and this is used for displaying and rendering to the player. So we're going to go back in and load the file again. Gives us the same error about the diffuse texture. That's okay. And now we can see as we navigate our level here. I'm going to click the textured button. Now it's even easier to see. You can see the path markers as well lighting up where they will be. The item boxes, the red coins are all displayed. From here, we would add details such as the preview image, the banner image. These you have to create separately and reference here. As well, you can set where the water level would be, where echo points will be located, and the colors of the sky. You can view the textures that you're using on the second screen and identify the sections and the objects that can be drawn in them in the following screens and the surfaces as well. From here, we are all set to build. So we're going to select the Mario Kart 64 ROM that we've already patched with the Overcart patch or the hot swap patch that's included in the download. Once we've selected that, we're going to select a folder to output the data to. I'm going to select this folder output. After a few seconds, it'll create a new ROM based on the original one that you provided with the additional level added. Now the place where the level gets added is this box down here. There's multiple sets. You can choose which cup and which course the level will replace. Once everything is compiled, we'll load it up and test it in the emulator. One second, that's small.
Welcome to Mario Kart.
Much better. Okay, so we're going to progress now and take a look at the level. Now your build will probably look different, as I'm using a very experimental version right now. Hopefully it still works. So here is our mystery level, because we did not use a preview texture or banner texture. But when we go to load it up, we'll see our level. You'll notice instead of red coins, I have Bowser's. Again, I'm using a very experimental build at the moment. But other than that, your version will play as expected, assuming that you use the correct patch. So we're going to drive around our level real quick. You can see we didn't make a mini map, we didn't make any of the textures, we were very lazy and just made a quick level. And there's a lap. So we've just done a lap on our new level. Bowser has just tripped me up and prevented me from setting a new record, another trip. So yeah, very fun stuff. As you guys can see, there's more to come. Custom objects will soon be a new thing as well. Hopefully this quicker, more streamlined tutorial will be a bit easier to follow, covering the entire aspects. Again, if you guys do have further questions, please do join the Discord server. I love helping new members and assisting people, and I especially love seeing new Mario Kart 64 custom levels being created. So thank you guys all so much for watching and for your support in the community. I want to thank everybody for playing these and just being a part, and the appreciation that we get. It's really great knowing that the work that we do is appreciated by others, and that we're not just playing these ourselves, as I always say. More exciting things to come. If you haven't already, click the subscribe button below. I greatly appreciate it. And until next time, you guys take care.